Alright, welcome. Today we're going to be talking about vectors and adding vectors and finding the resultant of that. And so here's a problem we're going to start off with. What is the resultant of the following vectors? It's not written, but these are all vectors. And so what we have is 24 meters at a degree of 36 north of east, 18 meters, 37 degrees east of north, 26 meters, 33 degrees west of south. So when you do these, the first thing you want to do always is draw a picture. Because when you draw a picture, you're going to be able to understand the concept a whole lot better. So there you go, we have our x and y axes. And we're going to go ahead and draw these. So 24 meters, 36 degrees north of east. So the starting direction is always the second one listed. So we'll start with east. So the starting direction is east, and then you're going north 36 degrees. So there's that. And there's 24 meters. Next one, east of north. Starting direction is north, and you're going east 37 degrees. And that's 18 meters. And the final one, west of south, starting direction is south, and you're going 33 degrees to the west, so it's going to be somewhere around there. And the reason you want to draw a picture is because you can almost estimate what the answer is going to be, or at least what direction the answer is going to be in. And if your answer doesn't correspond to that direction, you know that something wrong might have happened. So based on what we've seen, I'm going to estimate that the angle is going to be going in this direction, into this quadrant. So we'll find out if our actual numbers prove that correct. So let's start off by breaking each one of these into their coordinates, and not into their coordinates, into their components. That's what you want to do with every single one of these problems, is break them into their components. But before we do that, we need to make everything relative to this axis, all the degrees relative to this axis, because it makes it easier to think about. This one already is relative to that axis, 36 degrees. This one, however, is relative to the north axis. What we're going to want to do is, we know that going up, straight up and down is 90 degrees right here. From there to there is 90. But now with 37 degrees to the east of that, so 90 minus 37, so from there to there is 53 degrees. And I'll do the same thing here. We know from there all the way down to there is 270, so subtract 33 from 270, 237 degrees. Alright, now that we have everything in terms of this axis, we can begin. So we'll start off by labeling that A, that B, and that C. So we'll start off with A. You're going to have AX and AY. What AX is the horizontal, and what AY is the vertical. So with all x's, doesn't matter if it's AX, BX, or CX, you're going to be using the trig function cosine. And when you're doing this, you're going to start off by writing the magnitude, so 24 times cosine of the angle, 36. And now for the AY, start off with the magnitude again, 24, but for all y's, you're going to want to use sine. Again, the angle, 36. And now let's go on to B. BX equals the magnitude, 18, times cosine. Remember, we always use cosine for x. And we figured out what the angle was from this right here, so that is 53. And this just makes it easier when we're going through. It's not as confusing. So BY equals, again, the magnitude, 18, sine 53 degrees. Alright, move it up a little bit. Now we'll do C. CX equals magnitude 26, cosine, we found out the angle there, 237 degrees. And then cy equals 26 sine 237 degrees. All right, now we have broken them all up into their components. And you're probably wondering, what are we going to do with this? What we're going to do is we're going to add all the x's together to get rx and all the y's together to get ry. So we're going to add all the x's. So ax plus bx plus cx is going to equal rx. Your teacher might tell you it equals some other variant like vx or something, but it doesn't really matter what you put in front of the x. What you're knowing is this is the sum of all of the x directions, all of the horizontal directions. And the same thing for y. ay, ay plus by plus cy equals ry. So now we can go ahead and put ax plus bx plus cx into our calculator, calculate what rx equals, and ry. I'm going to go ahead and do this right now. So 24 cosine 36 plus 18 cosine 53 plus 26 cosine 237. And we are going to get 16. And now, on to the next one. ay plus by plus cy. 24 sine 36 plus 18 sine 53 plus 26 sine 237. And we're going to get 6.67 or 6.7 because we're going to significant figures. All right, now you're probably thinking, what do we do with this? What does that mean? Well, what it means is that's the new horizontal and the new vertical of what this is completely combined. So redraw your axes, x's, whatever the plural is. This is physics, not English. And we're going 16 in the x direction, so 16. And you're going 6.7 in the y direction, so 6.7 in the y direction. And what this is right here is this is the resultant of what that is combined. This is the direction that it's going to be pulled in, because these are all forces pulling in different directions. And so this is going to be the final force once everything cancels out and the strongest force is pulling. That's the magnitude of what it's going to be pulling at. And you can figure that out just using Pythagorean's theorem. You should know this: a squared plus b squared equals c squared. But if you don't, a, b, c is always the hypotenuse. So go ahead and put that into your calculator. 16 squared plus 6.7 squared equals c squared. Take the square root of that, and you're going to get c to equal the square root of 16 to the power of 2 plus 6.7 to the power of 2 equals 17. So the final magnitude equals 17. All right, now that we've found the magnitude, we need to find the angle at which this magnitude is pulling. So the angle, we're going to use one of our trig functions. In this case, we're going to use tangent, because tangent is equal to opposite over adjacent. And if you don't know how to remember this, you can use SOHCAHTOA, the acronym SOHCAHTOA, or some old hag caught a hippie tripping on acid, and that allows you to remember which one it is. So tan is opposite over adjacent, tripping on acid. Kind of weird, but whatever helps you remember. So tan theta equals opposite 6.7 over adjacent, I'll show you that that's what theta is, over adjacent 16. Now you're probably wondering, how do I figure out what theta is? Well, it doesn't make sense. So what you do is you do tan inverse, that's how you write inverse, of 6.7 over 16 equals theta. You can't just do tan to the power of -1. It doesn't really work that way. I'll show you how to do it on the calculator. It's a TI-84. You do second tan, and second tan gives you tan inverse. And then you can just add the numbers 6.7 divided by 16. Make sure you're in degree mode. And the angle comes out to 22 degrees. Now let's see if this backs up what we originally thought. Pulling at an angle of 22 degrees, which is somewhere around here, it's actually around here, at a 17, at a magnitude of 17. So our initial prediction does actually match what we got for our final answer. So that's how you solve this kind of physics problem.